Hello everyone, and welcome to today's presentation, step-by-step oil and gas borehole drilling process, hosted by the Society of Petroleum Engineers at the American University of Iraq, Sulaimani. Thank you for taking time out and being here today. I'm Pirsha Abu Bakr, the president at the AUIS Society of Petroleum Engineers. First of all, I would like to introduce today's presenter, Dr. Ahmed Salih. He's a postdoctoral fellow researcher at the Civil and Environmental Engineering Department from the University of Houston, Texas. He's currently a professor at the American University of Iraq, Sulaimani. He has published many research papers in international journals in areas of civil and petroleum engineering. Also, I would like to mention that this lecture is organized by AUIS SPE. Our chapter was established recently on July 15th, 2020, and our mission is to maintain and raise the standards of AUIS engineering students by fulfilling SPE's mission of developing technical knowledge and providing opportunities for students to enhance their technical and professional competence. Also, our activities are specifically targeted at AUIS students. We will try to make them public so that students and professionals outside of AUIS can benefit from it as well. And of course, you will see more lectures present by local and international lecturers similar to this one in the near. For those of you just joined us, welcome. A recorded version of this online lecture will be available. So if you miss anything, don't worry. Dr. Ahmed will present this lecture and we will have a question and answer session at the end. Please prepare your questions. We would love to have from you, Dr. Ahmed. Thank you, and please go ahead.
Okay. Hello, everyone. We will be talking today about complex composite structure ever in engineering department. Take a look for this name, complex composite structure. That is most complex structure ever in engineering department it can be seen, which is drilling borehole for the purpose of taking oil and gas out from the ground. Imagine those things, guys. We are talking about taking oil and gas, drill boreholes for more than 500-600 meters underground, for more than 800 feet underground. It's not shallow drilling borehole process as we are normally doing it in the civil engineering department or other engineering departments. In civil engineering department or other fields, we are talking about not more than 60 meters. That's in worst case scenario. If we have sandy soil or if we have some problems underground, we are not going to go more than 60 meters underground. But in oil and gas, we are talking about 500, 600 meters underground, even more. So for that, we will face a lot of problems. For that reason, we are going to use several types of the material. And those types of the material, we have to connect them together. We have to tie them together. It's difficult. As we are engineers, we know it's very difficult to tie two different types of the materials together. How about tying several types of the material underground together? That is one of the most challenges we can see in the drilling borehole for the purpose of oil and gas operation, taking out. The other points that we have to take care about, we cannot see what's going on underground. In other structures, mechanical engineering, civil engineering, other engineering fields, everything can be seen outside. So if you see any problem outside, immediately you can fix it. But in oil and gas, we'll not be able to see what's going on under 6, 7, 8, even 800 meters underground. That's another challenge. The other challenge, since we are talking about this deep of the operation, we will have two main parameters. We are studying it in the engineering department. All engineers departments are talking about pressure, temperature, pressure, temperature. So the material that we are gonna send it from the top of the natural ground level to the down of the borehole, how much pressure you want, at which temperature are you gonna work on? Take a look. Most of the structures outside in the other engineering department, they are not talking about more than 50 Celsius temperature. And they are not talking about more than 100 Pascal pressure or about 50 megapascal pressure. All other engineering departments are focusing on those two numbers. But in drilling operation, we are talking about 200 Celsius temperature. Can you imagine this number? 200, even 50 Celsius for the some of the part of the area. So it's even more than 100 Celsius is 200, 250. For the pressure that we are talking about in the oil well operation, we are normally talking about 1,200 Pascal. Write down this number, please, and just imagine. That's why Ahmed Salih talked about in the starting of the presentation about complex, composite structure ever. Yes, it is. Why? Because of the condition that we are working on. Temperature, pressure, depth, and there is another major point, guys. We are facing several behavior of the material underground. Several behavior of the materials. Take a look. Let me give you an example. If you are steel guy, you are mechanical engineering, so most of the material you are working on is a steel. If you are a civil engineering guy, most of the material you are working on is a soil and concrete. But in the oil well operation, you are going to work on all those materials. We'll see very soon in the videos and the slides. We are going to work with the soil, different types of the soil. How many types of the soil do you have? We are going to work on the rock, different types of the rock. How many types of the rock do you have? We are going to work on the steel, different types of the steel. How many types of the steel do you have? Also, we are going to work on the different liquid material. We are going to work on the cement, similar to the civil engineering departments. So all those materials are combined together underground. Look at the problems or challenges you are going to face to send those materials down, set them up, and then combine them up. Here is why. Because you are going to take oil and gas from the ground, and we must not have losses in the oil and gas when you take it out. If you have any problems for setting up those materials, for sure, definitely you will have losses in the oil and gas. And we are spending billion and billion dollars to drill those boreholes, since we are gonna take gold out from the ground. So for that reason, I have selected most composite, I forgot the name actually, most complex composite structure ever. Complex, it's a complex, it is. Composite, different types of the material. Structure, it is structure, but it's underground. Let's go ahead, see this video, and understand what will happen when you drill boreholes. Take a look for this video, please, and then we will be talking about it during the drilling process. Here is, we will have a shaft, core, and then connected with the bit, the head of the core, and then try to excavate underground. Temperature will be raised up for the bit. All the steel materials has a limit for the temperature. Cannot go more, otherwise it will melt underground. We will have particles for the cuttings underground must be taken out. Must be taken out. From how deep? From as I told you, not less than 500-600 meters, or 60, 70, 700, 600 feet underground. Take a look. So far, what we have shaft, we have steel part, and connected with the bit, head of the drill bit, and then it's going to drill different formations. As we know, rocks has a different strength. Limestone has a specific type of the strength. Sandstone will have a specific type of so each type of this rock formation, we have to use specific types of the bit of the head, and then temperature of the bit will raise up until 900 Celsius. Take a look at those numbers. Just imagine those numbers. 900 Celsius for sure is gonna melt. I have to use material will lubricate all around the shaft, so will reduce the temperature due to friction between the steel and rock formation or soil formation. Okay, so what else do we have challenges? I have to send that specific kind of, call it greasing underground. So that grease, we'll call it drilling fluids. Which type of the fluid it is? Of course, it's not water. Must be viscous than water. Okay, why? Because if you send water, will not be able to take those small particles out from the bottom of the borehole to up. Okay, what else do we have? Challenges so far. So far, what we have, pressure that we need to send that drilling fluid down. What else? We will have a stability problem for the borehole. Take a look, guys. We have a steel about 6 meters. Can you raise it up and fix it like straight line? It's impossible, because it's gonna tilt. It's gonna tilt the steel. How about that borehole, which is about 6 inches? 6 inches with a length of 500, 600 meters underground. we will have a weak types of the soil, weak types of the rock is gonna collapse, is gonna fail. That borehole is gonna fail. I have to fix that problem as well. We will see in the next slides, we will see how can we fix that challenges, which is stability problem for the borehole. Okay, if we go ahead, after finishing, we will face another problem, which is leaking, fluid loss. The liquid that I'm gonna send it, 90% of the liquid is water. I'm gonna pressurize it, very big pressure, up to 1000 psi. So that pressure will push the amount of water go through the formation cracks underground. Okay, so that's another problem, guys. For that reason, we will fix complex structure on the oil well operation borehole. What else do we have? Let's see. What else do we have? After fluid loss, we will face another problem, which is casing. We are gonna set up the casing down to make the borehole stable, and then setting up this casing down to make the borehole stable, so we'll not have a collapse in the weak layers formations. But in the same time, later on, when we take the oil and gas from the bottom of the borehole, we will face another problem. We'll have a leaking between the steel part with the formation, with the rock formation. So I have to now seal the annular space between which material? Between steel part, which is casing, and the formation. That's another challenge. Which type of the material are you gonna send? Silicon. I'm gonna call it silicon. Okay. How much bonding strength? Bonding strength. Sometimes we are call it adhesion. Adhesion between two materials, steel and rock, or steel and soil. I have to send material, can tie both of them, one side with the steel and other side with the soil or rock formation. Look at how many challenges do we have during drilling operation. Each of those parts, we have a chapter, we are talking about it in the drilling class, in the AUIS. But I'm gonna summarize it to you to know what is the main parameter, main factors that is involved in the construction of boreholes. So that is called oil well cementing. Stop pushing the cement in the liquid phase, cement in the liquid phase, cement slurry down to fill up all the gaps between the steel casing with the formation, steel casing with the formation. Take a look, guys. We have cement outside. Is it similar to the ordinary Portland cement that civil engineering guys are normally using it? No, it's different with that cement. We are normally in the civil engineering, we are looking for quick set for the cement, but here we are looking for low setting time for the cement until the process will be finished. Now I have set it up, the casing. Last part, I'm gonna remove the cement out from the ground to be able to take oil and gas from the voids. Let's go ahead and see other slide. Now, here is the bit that we are normally using it for drill rock formations. We have different types of the rock, steel, using for different types of the rock. This one, we are normally using it for limestone. Those others for shale and sandstone, they are weaker than limestone. Casing, here's some pictures. I'm going to show it to you. If we are going to face this type of the formations down, we will be able to fix that, make more stable using casing. Here is casing steel. We are going to push it down to push all around the wall underground to make borehole stable. If we are facing this gravelly sand or sandy gravel or weak rock, for sure, while you are drilling, this layer is going to collapse. Here is the pictures I will want to show it to you for taking sample rocks out from the ground. Here is the tube, which is core, made it by steel, as we can see it in the right picture. And then, as we can see it in the middle picture, we'll see inside the core, there is a rock. That rock will be taken out. How? I will show it to you in this video. That is pushing. Again, let's see it. Pushing, applying pressure, water pressure on the core. So the rock will be taken out from the rock samples will be taken out from the tube. And then later on, we have to transfer the samples, the rocks that we have taken it out from the ground. You have to transfer it to the lab to make some important tests. Important tests. Later on, we'll see why it's important, those tests. And then, now, this is type of the rock. One of the most important parameter you are gonna test it in the lab is you have to measure how much is porosity and void ratio. Porosity and void ratio. We'll be able to estimate amount of oil inside the voids. If you know the volume, we'll be able to estimate amount of the oil and gas inside the voids of or porosity of the rock that this sample. And then there are other mechanical properties also must be known. We'll come to it briefly, very quick. What are those mechanical properties must be known for the rock and soil. Take a look, guys. We will, during this process, we will see the it's coring, the using the bit drilling. Take a look, the shaft that's there will during the friction with the formation will temperature will raise it up. And now I have to use liquid. That liquid we are going to spend time about it. What the liquid is? That liquid is not water. Is denser than water. Is viscous than water. Why? Because I need to take all the cuttings down from the borehole to up. I will raise more. I will reach more than 600 meters. So I have to make sure the cuttings, small particles of the gravel, small particles of the soil will be taken out. So that material is another challenge to be prepared in the oil well operation. We'll call it drilling mud. Drilling mud. From its name, word mud means it's water plus clay. Mud word is a water plus clay. But what does it do? How much is in the composition? Normally, we are using about 90% water, about 10% clay. So mix them up send it down by specific pressure, so that mud will be able to clean all the cuttings, small cuttings made by drilling operation. What is the main objective for using mud? Is for minimizing formation damage, because that mud is gonna seal all around, the borehole. It's gonna seal it, paint it, like kind of painting. So we'll reduce the formation damage, and then we will also, other one, as I told you, reducing the temperature for the bed, and then also we'll have cooling and lubricating the steel part while it's connecting with the rock formation. Very quick. Also, we have different types. I'm not going to spend too much time on the types of the drilling mud. We have oil-based mud and water-based mud. Properties. That is, if you are working on the drilling operation, you have to follow the instruction made by API. API is like ASTM in the construction or ACI in the mechanical engineering departments. They have a specific code, it's called API. That API will give you the specific properties of the density, rheological properties, and fluid loss. So if you are supervisor engineering in the field, what you have to do, you have to take those numbers out, you have to test those numbers out, you have to get it from the lab, and then bring those numbers based on pressure, temperature underground, depth, type of formation, those four. You will decide whether if it's that drilling fluids or drilling mud, it's suitable for using drilling operation in that depth or not, at that temperature or not, at that specific types of the rock or not. So you will decide based on what? Those four parameters: depth, temperature, pressure, and then types of the formation. Okay, density, as we know, all of for the engineers, major properties of the materials is density. We will be able to measure density by using a portable device, can be carried out in the field very easily. Here is the rheological properties that we have to use it in the field. What is rheological properties? Actually, it's a relationship. Rheological properties, guys, before I forget, it's for two types of the material you are going to use it. One, drilling fluids or drilling mud. The second thing is for cement in the liquid phase. Cement, when you send it, cement slurry, when you send it down, you have to take those properties out, rheological properties. What they are rheological properties? It's two types of apparent viscosity, plastic viscosity, yield point. How can we get those parameters? Actually, it's a test, will be done using viscometer between shear strain rate in the x-axis with shear stress in the y-axis. And then mathematically, not experimentally, you have done it experimentally, the relation between shear strain and shear stress. But now, mathematically, you have to take those parameters out. Otherwise, you will not be able to use that drilling fluids in the field. Otherwise, you will not be able to use that cement slurry in the field. You have to take those numbers out. You have to be familiar with. And then comparing those numbers with the API based on pressure, temperature, types of the rock, and depth that you are working on. You will be able to select, tell them this draining fluid is suitable or not. Tell them, tell the quality, it's a quality control for the material, that the cement slurry is suitable for that depth or not. Okay, so here is some information about the viscometer. Normally we are using it for relationship between shear stress versus shear strength. As I told you guys, each of those topics is a chapter by itself in the AUIS. We are normally studying it in the fall. And then here's the relationships. What you are going to take from the lab, red points. Red points is a lab measurement. And then the rest is a mathematical measurement. What is the rest? It's a yield point, plastic viscosity, apparent viscosity that we just talked about. Here is some equations. We are normally using it for taking rheological properties, plastic apparent viscosities plus shear stress or shear strength, initial shear stress. I'm sorry. So we are done with drilling mud. We have another liquid, as we saw it at the beginning of the video. We saw liquid, other liquid. It's a cement, but in the fresh case. Cement in the slurry. So that cement also must be pumped down. Must be pumped down. And it must set not quickly. It must take time for setting the cement. It's not like it. And normally our cement that we are normally using it in the construction is not carrying this much of temperature. How much that oil well cement must carry? About 280 Celsius. Boiling, water boiling is 100 Celsius. Water when boiling is 100. But in this case, now we are working on the 280 Celsius. So that liquid slurry also must measure. I'm sorry, let me turn this Viber out. Okay, now it's okay. This cement slurry, we have to measure rheological properties of it. Same thing. Go to the API. Go to the API, and then from the API, we'll be able to know how much is that cement slurry is possible to be used in that depth for that material or not. It's noising, actually, noising. Let me just turn the Viber. Sorry, guys. Okay. Now, I'm sorry for taking few minutes. I'm gonna take a few minutes for your time. Let me turn that Viber. Just 1 second. Okay.
Please, I suggest all of you to mute your microphones. Thank you.
Okay, thank you. So now, what those are the mechanical properties we have to know for the rock formation and the soil that you are going to take it from the ground for the purpose of the oil and gas operation. First, strength must be known. That's the chemical composition of the rock and the soil must be known as well. Bonding strength, that is major test, guys. Bonding strength is a major test for the drilling operation in oil and gas. Since you have different types of the material combined together, we have the soil, we have cement, we have a steel. So we'll have also the drilling mud. Fracture mechanics, that's another major properties for the rock must be known. From the fracture mechanic, we'll be able to know how much losses of the fluid that we will have. Permeability, of course, you are working on sending the liquids down and through the porous material. Porous media is called porous media. Rock and soils are porous media, and you are injecting water. What's going to happen? Water will go through it. So I have to minimize that amount of water. Also, we'll have a compressive strength. From the compressive strength, we'll be able to know how much is the rock is good enough for the strength or not. All those numbers will be compared with the API values. Pucker test is a type of the permeability test for the rock, will be done to measure permeability of each layer. It's called Pucker test. Okay, we're going to start with permeability test using Pucker test. That is another important test must be done for the rock formation in the field. That is some information about Pucker. That's what we talk about fluid loss. Fluid loss is a major challenge for the drilling operation. Since you are going to send liquid down, for sure, porous media will take amount of water, and we are as engineers, we have to stop or minimize the amount of losses for the water. Some information, I'm going to go a little bit quick because of the time on the slides. That is the test. Normally we are doing it in the lab to measure the amount of the fluid loss with the thickness of the filter cake. That's the relationship we are normally getting it. Based on the API, it's recommended to get for 30 minutes, for the 30 minutes fluid loss. And then after that, we will have a cake filter. That cake filter is representing the thickness of the cake around the borehole. That's called cake filter. Very recently, yesterday, me and with the group, we have published international journal articles about not minimizing fluid loss, even stopping fluid loss. Make it zero. Take a look. Here is the journal, international journal we have published. Of course, collaboration work with the University of Houston, Texas. So that is, we have stopped. Means something is kind of injured, and we are stopping the blood coming out from the body. Similar to that, we have stopped, as we can see it in the graph, for testing up to 400 minutes. So we had zero fluid loss. That's been accepted internationally. Some information about mechanical properties, modulus of elasticity, compressive strength of the rock. And then we have last part of my presentation is drilling operation problems. We have talked about some of them, and the rest we are going to finish. What are those operation challenges we may face it as an engineers in the field? First, pipe will stick. Pipe sticking, since you are going to send pipe down, you may have a shell or clay layer. That clay layer or shell will stick with the pipe. You cannot take the pipes out. That's major problem. So several times you are reaching 100 meters and the pipe will stick and it cannot be taken out. That is one of the major problem in the drilling operation. Other one we have, as we have just talked about, is a fluid loss. Amount of the water will be lost through the porous media, through the soil or rock. Hole division, that's another problem. We will have it in the field. Other one is material damage, pipe damage. Pipe will fail. Pipe that we are going to send the water or drilling mud or cement slurry down will get failure. Here is some pictures regarding to the pipes when it's failed. Take a look how the when it's failed and you are applying about 1000 psi. Look what damage you are gonna see it in the field because of that high pressure and suddenly failure due to any reason. Another problem we have it in the field, we may see it most of the area in Iraq, is when you drill, the formation has a gyps between the rock layers. As we can see it, it's a gyps, it's a salt. So that gyps will be dissolved. When it's dissolved, that will have a cavities between the clay rock layers, and we will have a lot of fluid loss. Plus, that amount of the salt will reduce rheological properties of the cement slurry and the drilling mud. When it's reducing, I know I have a few minutes more. I'm going to go a little bit quick. So when it's reducing, rheological properties is another challenge in the drilling oil operation. Borehole instability, as we just talked about, we may have a gravelly sandy soil or sandy gravel soil or sandstone of the rock. When you drill, that borehole must be set it up, must be installed very well, otherwise we will have a collapse. Mud contamination with the amount of the salt. Shell instability. Shell layer is a clay. Will have will expand. That clay, when it touch water, will expand, will swell. When it swell, that will stick with the shaft and will not be able to take the shaft out from the boreholes. That's it, I think. If you have any question, please ask me, and feel free for ask any question regarding to drilling operation oil and gas.
Thank you so much, Dr. Ahmed. It was a very interesting and informative lecture. Please, if you have any questions or comments to make, you can ask Dr. Ahmed.
Feel free to ask any question, please. Even if it's not in your major, please ask.
Excuse me, may I have?
Sure. Okay. Go ahead, please.
Thank you so much, Dr. Ahmed, for that lecture, and it was very interesting.
Very welcome.
And thanks so much for the organizer. And I'm wondering if we will have similar lectures in the future, based on similar. We are diving deeper into the similar topic that we have talked about today.
Yes, sure. For future, we are planning to have more detail about each part individually. So we just talked about today about the all of them together. Properties of the porous media, properties of the liquids material that we are going to use, properties of the steel, properties of the rock, all those topics, we should have a chapter lecture talking about it in the future. Yes, for sure.
Thank you so much, Dr. Ahmed. Thanks so much.
Very welcome.
Any more questions?
Please, if you don't have any question now, send me email, So the more information, more lecture can be sent to you through the email. Very welcome anytime.
Well, okay, I would like to thank Dr. Ahmed Salih again to talk about this important topic, and thank you to all of you watching and listening, especially those who were with us right from the beginning. Stay safe, and everyone, and thank you so much again.
Thank you so much for your time.